If I could invite our panelists to come and take a seat. Being the first panel of the conference is always a special honor because it shows that they trust you and it gives you the opportunity to work out the technical issues that the other panelists will get to follow. We have a presentation over there. There's a clicker if you'd like it. Your presentations are downloaded in the bottom. If you want me to run back and forth and open them for you, I can. Otherwise, I'd ask each speaker to open their presentation. Is that okay?
We'll figure it out.
Thanks. And I do want to thank these first panelists for their indulgence in being the guinea pigs for working out the technology, because I know that's always a little bit awkward. This first panel on NASA integration does bring us some controversial issues, and we will have a question and answer period after the end of all of the presentations. And Moriba talked about being candid, and that's important, because this is a controversial topic, and we shouldn't shy away from that. And we shouldn't shy away from some very overt discussions. I understand that the space community says, we're only 40 to 50 launches a year, we're not the problem. You're 70,000 flights a day. But then the aviation industry says, yeah, but you take 1,000 times the airspace in order to do it. These are valid points. And when it comes to integration, we need to look at the needs of each other and the limitations and the possibilities. And integration comes when there is that open communication. So when you're thinking about your questions, don't shy away from the provocative questions. That's what makes a conference interesting and also valuable. We have a very distinguished and experienced panel to start off this morning. And I'm going to introduce them first, then they'll present their papers, and we'll have the Q&A. Our first presenter will be Stephen Browning from ALPA. He is the ALPA representative for commercial space integration. He has 20 years of flying experience with United and 30 years experience in the military, including as deputy director of the Air Traffic Services Cell. Sitting next to him, we have Catherine Bolczak, Katie, from Mitre. She has 25 years experience with FAA research, and that includes the breadth of the FAA work: traffic flow management, flight service, cybersecurity, and integration of launch and reentry systems. She is currently the Mitre principal investigator for Space CDM, collaborative decision making. And the collaborative decision making paper she's going to present, I think, will also be very provocative. How do we work together? Next to her, we have Sven Kaltenhaeuser from DLR, the German Aerospace Agency. He's in charge of the German Aerospace Center and the Air Traffic Validation Center there. When it comes to modeling, you'll not find anyone more knowledgeable than Sven. He represents DLR at the FAA Center of Excellence for Commercial Space Transportation and is currently working on high-altitude operations and commercial space integration. And finally, next to him, we have Janet Tinoco from Embry-Riddle University. She's currently researching spaceport business models. Dr. Tinoco is an expert in strategic planning, serves on a panel of the national academies. She's worked with the Kennedy Space Center on public-public partnerships, getting organizations to work together. These are key elements. So let's give a warm welcome to all of our panelists. And Stephen, if you'd like to be our technology guinea pig.
Yes, in many ways, I get to be the guinea pig today. So I guess, sit down low. All right. That looks familiar. One last step. Okay, who's my F5? There we go. Nope.
I think it's hidden under your menu. No?
Exactly. That's what I was trying to get to. A little.
Oh,
there we go. Aha. Bear with me, because I will say, she mentioned I have roughly 30 years of experience in the Air Force, 20 years at Airlines, but I get also admit that this is my rookie experience on a panel like this. And I get the unenviable task of following my true leader there, Captain Joe DePete. So please bear with me and be gentle with the questions, as, like I said, this is my rookie experience. So this, the ALPA white paper, addressing the challenges to aviation from evolving space transportation. I'm not the author, and I am truly a volunteer that came to speak about this because I wanted to. This was a true effort, a collaboration effort. You'll hear those themes a lot in the next few minutes from me. Collaboration, safety, and integration. Those are the three key words that we'll be using today. This was a true collaboration from our leader's vision, Captain Joe DePee, from our outstanding professional staff, the multitude of personnel that put this paper together to really show the way we feel about this evolving operation. And volunteers like myself. As he said, 61,000 people of ALPA. The pilot representation is volunteers. So I'm here simply because I want to be here. Just real quick, run over a little bit of background. Real quick, this is just a synopsis. The 15-page white paper is a nice little read, so when you do get a little time of your own, I know it's all precious time out there, please take a moment to read this if you have not. It gives you a little bit of understanding, a little bit deeper dive, a little bit more in the weeds as we talk about on the subjects we're going to discuss and what's important on this integration piece between the tried and true methods that we're using nowadays and the evolving space operations. We'll talk about some of the challenges, and then in the end, I'll give a few of our recommendations that we've come together, which tie in closely to our conclusion. Early development of space. This was a government entity. We used these operations mostly on the coastal areas. They were very small in number, and the regulations were built around these operations. Since that time, every year, we saw the commercial space come into it. And you'll see throughout our paper, we try to delineate that difference between the three entities, basically. When we mention there, civilian and government agencies. On the civilian side, what we're talking about are those companies out there, those non-governmental organizations that are working directly with the government to launch that government-type mission, i.e. SpaceX is now a big involvement, where they do change into that pure commercial piece. And as you can see there, that licensing was all based off those initial launches, that small number and small locations, mostly on the coast. And now we've seen the evolution, right? We went from a very small group of launch sites, now that's greatly increasing. We'll talk a little bit more about that. But the big part there is now we've seen that change just over the last few years. In 2017, you'll see, 78% of launches were categorized purely as commercial. So that leaves only that small piece. 72%, sorry. 28% for governmental operations. 72% for the commercial piece. So you can see where that paradigm needs to change. The rules need to change because they were based off that small number. Now that great increase that we're seeing nowadays into what has now become the space operations led by the commercial space group there. So now we talk about the regulatory differences. Captain DePete really brought that up. Those rules were based off past accidents. The sheer number that we have, the thousands and thousands of flights, allow us to make sure to go back and get that feedback to make sure that we're doing it right. And we've proven that now by statistically being that safest form of transportation out there. Now you take the FAA working with this new entry. The technology's changing. The speed at which all of the operations are moving along in this commercial world is much greater than what we've seen in the past. We're evolving. That integration piece needs to come. We know that. We're part of that. But we also got to understand that these rules were written at a different time. So they need to evolve as well. And that's that part that we need to make sure we're going along with. As pilots, we are regulated extremely heavily. But we do that so that we can be the safest form of transportation out there, and we succeed in that goal. The separate requirements in those regs, breaking them out, it almost becomes a cut and paste job of what does work. But it is over time that we'll figure that out. But it's not there yet. We're still not there. The regulations that are in place are separating and segregating the operation. We are not fully integrated from the technologies that are on the aircraft to the training as well as we speak here. They're not integrated. So to do that, we need to go from this segregated airspace to integration. This is the areas that we highlight to make sure that we're doing that. The last line there was also about the government, right? The government is going to stay segregated. There's no plan right now to change, to integrate the space operations of government And obviously, there's just not a safety concern there. There's also a security concern as well. And so there is no plan for that. But as we successfully integrate on the commercial side, expect to also see that done for the government as well. So 2 real quick regulatory differences that we'd like to kind of highlight. We talk about the Commercial Space Launch Competitive Act of 2015. The language in there really is to promote growth and the commercial space operations. We understand that. We fully are aware of what that means for us, again, to go from this segregated service to the integrated force. It truly encourages that private sector investment. And it also understands that the regulations also have to morph as well as this integration comes along and we start moving all of those outlier locations along the coastal to inland operations. One of the big points there is the Act prohibits the FAA from regulating crew and passenger safety. Key word there, passenger. The other word they're trying to stick with right now, as we evolve, as we go through this learning process, is the difference between a participant and a passenger. I carry passengers. The space, as they're going into this experimental phase, will be using the word participant to make sure that every person that is on that aircraft understands that they are a participant, not just a passenger, and following that lovely passenger Bill of Rights out there. So that is a big stepping point that at some point we're going to have to transition from that participant to the passenger. The other big piece of legislation from the back of the room there, see, the AST was formed. They are responsible for all the licensing on the space piece. Where we are dealing more with the air traffic organization as well, the AST piece is handling the licensing of these aircraft. Each one of these operations are singularly licensed. They're not a whole entity such as we see with the integrated portion of traditional aviation. With that, the commercial space is responsible for making sure all of those pieces are lined up and all of those requirements are met, but it is only for that one operation. So each of these operations that we see out there in the commercial space world are singular entities, and that's where we highlight that, where you go from a segregated to an integrated. To be integrated, you all got to be coming from the same sheet of music. We all got to be talking the same language. We all have to have the same equipment to understand that relationship, to cooperate in the same airspace. As we saw with the spaceports, over time, they're popping up almost every day, right? We're seeing tons. We're up to 10 spaceports as of 2018, over 9 states. Huge difference from what we saw from the old government on the coasts. And that's where we see this big change in the airspace. It's easy to just use that airspace that's already segregated off the coastal areas. But now to drop that special activity airspace in the middle of the United States creates a whole new dynamic, both for safety and for efficiency. But we want to make sure that that's clear, that it's not just about efficiency when we're talking about going around these large airspaces, but it's also about the safety that's involved. A couple of more of these integration challenges we see. That large area of what we're talking about, it's segregated airspace. It does create disruptions, known fact. We highlight some of that in the paper as well, using the SpaceX example. But we understand that we need to get to that integration piece. But right now, the rules and regulations are not in place to fully get to that integrated piece. And so that large segmented airspace needs to happen until we can fully integrate. The space vehicles, as I mentioned earlier, they don't exist. A pure separation standard, the certification piece is for each individual aircraft, each individual player in this, not as a whole entity such as the airspace we are now working on. The flight crew portion, as I said, it's very, very detailed on my qualifications. It's not so for a space pilot. We'd like to see that come along because as we've seen, as we evolve with that safety piece with the Colgan crash, that being the impetus, right? We are trying to get to that next level where every space operator, pilot, space pilot, will have that same level of experience and scrutiny, for that matter, being it through the medical piece as well, that we have as traditional airline pilots. The other piece that we try to bring out is that, and Captain DePete mentioned that very much, is those enhanced tools. We need to be able to speed up and catch up with the technology that's out there when it comes to the regulation piece. That is tough. Coming from the great technologies advances that are happening every day out there, to be able to turn that right around and turn that into a usable product is very difficult, because you are mixing the old try and true with the great technologies that are out there today. So that piece that we always talk about is the CNS, the communications, navigation, surveillance. Those technical pieces need to come together between what's available to us right now and what's out there in the future. And we need to be able to integrate those so that we can cooperate. And we can, again, sing from the same sheet of music. So we talk about that with the Captain DePete also mentioned the mixed risk levels. Much greater level of risk, everybody understands that, for space operations than what is happening out there in the NAS today. Before we can integrate, we need to close that gap between what is considered a safe operation in the NAS right now and what is considered safe operations in space operations. Before that can happen, we need to segregate with the full intentions of integrating as time goes by. And what we mean by the hybrid use of the FARs is that designation between when does that space aircraft become a real aircraft, transiting the same airspace. To do that, it should have the same equipment on board. It doesn't right now. So again, that's that talk of you're taking a horizontal launch aircraft. It's an aircraft until it becomes a spacecraft. It should have the same equipment on board that every other aircraft next to it has on board that is required by the FAA. Those requirements need to be met. And then the no near-term solution, there is none in place, but we are progressing, and we're trying to get there. So, as a team, we've come together, and once again, I am not the author of these, but I am the user of these, and I truly believe in every bit of this. As a volunteer, these are the ones that are starting to say, this is the direction we would like to see go. The safe integration without the same safety standards, it's got to exist. Before we can integrate, we all got to be on the same level of safety. The segregated airspace operations, until the policies are fully developed, need to be in place, and we need to not degrade that safety level. The CNS requirements have got to be there. Same equipment, same type of aircraft, same airspace. With the full understanding that we got to develop those new technologies to get into that airspace as soon as possible. The adequate resources, funding. Right? Great theories out there. Now we got to put them in action, and we have to pay for them. So as a team, we got to all come together and understand what is out there, what are the best capabilities to move us forward, and to have that operational requirements catch up with the technology available. We have to collaborate. Again, that key word. We have to come together as a group, take that tried and true experience that we've done over relatively the last 100 years, and use it going forward together as a team. We need to make sure that collaboration piece, we're all talking together, and we're all coming together in great venues like this to be able to talk and use the access from our experience in the technology going forward. The training and licensing, we feel, is a big part because we've seen it and it's successful now. We need to move on from there. Developing the space vehicles airworthiness standards, just going to hit it one more time. Conclusion. Big one right there, safety. You've heard it over and over again from Captain DePete. Safety is core to our value. It's everything we stand for. The traveling public we have in the back of our aircraft and who are even on the ground, everybody in the United States, this is a key aspect. The next piece we're talking here, we got to understand your job just as well you need to understand ours. It's not just about efficiency. It's about this safety piece and making sure that everybody understands we're not talking just about the extra fuel on board my aircraft. It's making sure that the operation is safe. And the last one there, the collaboration piece. That is key to as we move forward. So thanks again from the 61,000 volunteers from ALPA. We appreciate your time today.
Thank you, and what a great segue into your presentation on collaborative decision-making, Katie.
Oh, it's me, okay. Great, can you hear me? Okay, great. Let me... Looks like mine.
Yeah, they're down there on the bottom.
The black background. Okay, this is there. Good morning, everyone. Thank you so much for the opportunity to speak to you today about this concept that Mitre has developed. It's a concept for launch and reentry collaborative decision-making. This is Mitre independent research. We started about October 2017, which coincidentally is when there started to be a lot of conversations about collaboration. I would look at this as a straw man concept, and again, we do have a paper, so if you're able to read it and give comment, and I'd love to talk to people during this conference about this research as well. We've started socializing it, but we have not done a lot of socialization, some FAA, some industry. But what we're finding in our discussions is that it does seem to be paralleling what is coming out of these ARC and other discussions where collaboration is coming up. And I have to say I've heard so much of introductory material that's really helped kind of set the stage for what I want to talk about here. Let's see if I can pick the right button. Okay. So the reason we decided to do this research was that we saw an opportunity. And the opportunity is to make better informed decisions on shared resource use. And we've already heard, okay, the National Airspace System is a shared resource, and it's also a finite resource. There's many users of the system. We've got commercial air transportation, general aviation, military is a huge user, commercial space, traditional space, and other and new entrants as well. So I think as folks are aware, typically a launch or reentry is going to require having one or more aircraft hazard areas. And this is the segregated airspace concept. But one or more AHAs that have to be avoided by non-participating aircraft, again, for safety. Now, this airspace system, I didn't mention at the beginning, is that it is managed by the Air Traffic Organization. So we have the AST, the Office of Commercial Space Transportation, and then we have the Air Traffic Organization that is responsible for managing the airspace with all these different user constituents. This AHA request typically comes into the ATO, the Air Traffic Organization, about 10 or 15 days prior to the mission happening. And at that point, typically the ATO really is going to accept and approve that airspace request. And in the current paradigm, this works because there just are not that many missions right now. So the issue is that these impacts could be harder to absorb as the operations grow. And we've heard that there's a whole fleet of different vehicles coming on board. We've heard new spaceports and the like. So how can we address these airspace demand issues? What can be done? So in some cases, it may be possible in the segregated paradigm to have options for the airspace. What we're showing here is actually an instance where the AHA is very large, and it's out over the Pacific Ocean. And in this case, it was a second stage rocket deorbit burn. And it already orbited several times, and that's why this airspace is so big. And the nice thing is it's a nice big picture that everyone can see. But the idea is that the operator later was saying that, well, we could have relocated that aircraft hazard area or perhaps done it at a different time. But they didn't have any information from the FAA to help make that decision, or they didn't even know to explore those options. And you really have to explore those options early enough that you're going to still be successful in the mission. So what we've seen is that CDM has been in practice for many, many years, and it provides a proven model for collaboration, understanding stakeholder perspectives, and resolving some of these airspace challenges. And the opportunity for the operators right now is to get in on the ground floor and have a voice in creating this future. So when we started the research, one of the first things we did was sort of go back and say, gee, what happened with CDM? How did it start? What was going on? And so this was in the early 1990s, and deregulation had happened probably about a decade earlier, and flights were increasing, and the congestion was increasing, and there were more delays. And at the time, the FAA was taking in flight plans from the operators, but had little additional information to support their decisions. So if there was a thunderstorm or some kind of issue, basically the FAA unilaterally figured out what to do. So then the idea was, well, how about if we have a new concept for collaboration and increased data exchange? And the operators, the FAA can tell the operators, these are the constraints that we're working with today. And the airlines can say, well, here's how I would prefer to manage that constraint to help, to work with my business model. So the approach when they started CDM was to do a pilot program to validate the concept and the benefits, sort of gain confidence in the process, and start to build some trust among each other. So that's a major piece of CDM. So the result was that it was created in 1995 as a joint FAA industry activity. So it's going to work together, collaborate, understand perspectives, and collaborate to resolve issues. So I think we've heard this from a few times now, a few people. Another thing that we wanted to do, so we're thinking about, okay, CDM for space, what does that look like? And if we go back and we compare the two industries at the time that CDM was being broached. So if we go back to air transportation in 1993, over 10 million air carrier and air taxi flights a year, as opposed to in 2018, we had about 35 commercial operations. If we look at the diversity and the maturity of the industries, again, very different. Air transportation is relatively stable, similar kinds of missions and performance across aircraft, but of course, different companies have different business objectives. They have different ways that they're going to be doing their business. Commercial space, as we've heard and seen, is constantly evolving, has diverse vehicle and mission types. So it's going to be, CDM is going to be very different for the space operators. We see it as going to be, it's probably going to be a leaner process than it is for airlines. But again, it has to be a structured process. And these user groups do have common interests. They want to have transparency. They want to have predictability of their schedules. So again, CDM is the way forward with that. So we came up with a definition. What is space CDM? We said it involves space operators as members of the National Airspace System user community. It involves them in some very important ways. One is to improve airspace efficiency during the mission planning through timely exchange and informed use of airspace schedule information. The second is to improve airspace efficiency during mission operation through timely information sharing to enable improved air traffic management procedures. We hear a lot about we want to have dynamic airspace procedures. Well, you need to have certainty about that launch and reentry operation to help affect that. And then the third is to improve the operations over time through feedback exchange and identification of new procedures and capabilities. And a part of it is collecting data. We hear, the airlines, there's tons and tons of data. We don't have so much data from launch and reentry operators at this point. So the bottom line is the operators are exchanging their perspectives and data to improve situation awareness and make better decisions about the shared finite resource. This slide is really just to sort of point out that the puzzle pieces have to come together for launch and reentry to happen successfully. So we basically have several different perspectives involved, and all these pieces are going to have to fit in the end. Okay, so for our concept, this is the scope of space CDM. So again, as I was alluding to earlier, it's going to span the what we call three operational phases. One is launch and reentry planning and scheduling. The second is the airspace management and mission operations. And then the third is post-event analysis and operations improvement. And that's what we call the operational pieces. And then in the middle, we have something that we call strategic collaboration, and that is getting to the agreements and rules that's going to be the foundation and sort of set the stage for what is done operationally. So the strategic collaboration, foundation of the operational process and stakeholder engagements. So the kinds of things that are going on in the strategic collaboration are we're identifying and prioritizing our challenges, developing the processes and procedures needed to address the challenges, identifying and developing the supporting data and tools, and then agreeing on standards and the rules of the road. I give the FAA data, the FAA responds in a way I expect. The FAA provides data to me, and I'm giving data back to the FAA in the way that that's expected and the kinds of exchange patterns that are expected. We're showing here that we have the FAA and the airlines and the launch and reentry operators all in the strategic collaboration, and others as well. And I agree that they do have to have, there are a lot of commonalities and areas where everyone needs to be involved in collaboration. But there's also some areas where it's really sort of more isolated to a particular sector or an industry. So, there's things going on with the airlines that the space operators really don't care about, not going to affect them that much, and vice versa. But then there's some areas where there's definitely is very strong interaction where they do need to collaborate together. So when we were developing our concept, we developed what we call planning concept elements, and all of this is in our paper. But we have them for each of the 3 operational phases. And what I'd say is that when we look at these, it looks rather simplistic. It's just one operation, one guy planning or executing or doing post-analysis. But we have to keep in mind, again, multiple operations in various stages of planning and execution and post-analysis, along with the thousands of flights every day and the hundreds of military operations that are going on. So in our planning phase, we're really talking about that initial winnowing down from the flight operator, from the launch and reentry operator perspective. I have a requirement from a customer, I have this payload, I need to deliver at a certain point, certain time, and so I only have so many options I have that I can do that, in which I can do that. But if you have a set of options, and maybe some preferred options, part of it is getting that early interaction with the air traffic organization to exchange some actionable information. So the launch and reentry operator can choose something that maybe is not going to be as impactful on other users. But again, we don't want to jeopardize the mission, but there are cases where there could be changes made, and especially as we have new types of operations. Like some of the suborbital may have more flexibility or different kinds of flexibility than what we've seen with the vertical orbital launches. So we have these concepts, elements. We're exploring airspace for use. So before we even get onto the schedule, it's sort of like, well, what's times that look busy or maybe not so busy, and maybe I can adjust my plan early enough in my planning to accommodate that and make it less impactful on other users. Then we have a scheduling and sharing of the mission information. So again, there's more information shared broadly, and that's one of the things here is how do we ensure that we're only sharing the information, that the right people are getting the right information, what information is exposed to whom and when. And then we have strategic collaboration on the launch and reentry. So we have maybe an issue. I only have so many options. My options don't seem to fit with this airspace congestion. What do we do? And then there's processes to work that out. I'm doing it on time. I can't see the clock.
You have 1 minute.
Oh gosh. Okay. We have each of these elements. We have an operation one, and that's going to be again providing that certainty to enable those dynamic management of the airspace, and post analysis. We're going to have mission specific post analysis and baselines and trends and metrics. We have to have meaningful metrics for the launch and reentry operators. What are they experiencing during this operation, and then how are they doing? Are they providing the data that they said they would? How are they performing to plan? Things like that, which is done in CDM with the airlines. Just quickly, we have identified 9 capabilities and identified some high-level data exchanges You would recognize that some of these capabilities are already in prototype or possibly in being procured. Some capabilities might be something that the industry itself would develop. But the idea is that CDM and that strategic collaboration is going to help put this picture together and build, figure out how do we build this picture. Skip these slides. And just the outcomes. So for all NASA operations and users, we'd have enhanced situation awareness and informed decision making. Basically, better use of the airspace for all users. NASA operations more stable because we have consistent processes and improved schedule predictability. And for space operators, basically getting their voice at the table. So they're helping to build the future instead of having it built for them. That's all I had to say.
Thank you.
Thank you.
I have a stopwatch on everybody.
I couldn't see, the clock was hidden over there.
So, Katie, that was great, and it segues very nicely because we've been talking about the U.S. airspace, but space is a global industry. And even if we are just talking about the U.S. industry, we launch from other countries. There are global decisions that need to be made, and working together is a very important part of that. So our next speaker, Sven Kaltenhaeuser from DLR, will give us a perspective of what they are doing in Germany.
All right. So, ladies and gentlemen, thank you very much, Ruth, for the kind introduction. Pleasure to be here today and giving you a little bit an introduction to the European perspective on a very specific topic, so not the broad view, but you will see what we came up with. So the idea is to, first of all, present you our method of assessment of impact on air launch operations on air traffic in Europe, on base of a use case. So I will start with some background and motivation information, then introduce you to the air launch use case we have put into our simulators, then talk a little bit about methodology and modeling itself, the simulation results, and then come to some conclusions, hopefully. All right, where to start? Background motivation. This is a slide maybe which is not that much appropriate for this room because most of you will know why we are here. So we see an increased demand and launch numbers in the past, but also in the books for the upcoming missions. There are a lot of new players, new vehicles, and also new operational concepts around. So the landscape is changing, and we have to adapt to that. And also, let's say, within the near space region, which is the region, let's say, above the usually used airspace for air traffic, but still beyond orbital operations, we have a lot of new users and diverse mission ideas, new vehicle types. So we have to put all this stuff together. So that's basically where we are starting from. Why are we bothering with this stuff in Europe? So there is, of course, also an increased commercial interest in launching from Europe. You might be aware of several activities going on in several countries in Europe, UK, maybe the front runner at the moment. But there are also activities to get new spaceports and space operations starting in Sweden, who are very experienced in launching sounding rockets, of course, but also in Italy, in Spain. We have interests to be noted in Portugal and also Norway. So there's a lot of activities going on, actually. There's also an increased national security interest in launching from Europe. Independent access to space is something which has been discussed. Also avoiding reliance on classical launch sites and single operators. So this is also something to take into account. Interest also in landing reusable spacecraft in Europe. Dream Chaser discussions were going on also in the past. New hypersonic passenger flight concepts, maybe a little bit far out, but discussed already. And an increased overall number of objects, and we will learn a lot more about that later on. So discussing that with ESA, for example, on how to, interact and make sure that we keep safe in that regard. So with all that taken into account, why talking about air launch as a use case? So we put our research in a place that we want to study possible impacts and interaction between space vehicle operations and air traffic management and air traffic control on base of a use case approach. The air launch use case was one of our first use cases we could think about. And the idea was there to have focusing on that, especially because of the advantages that might bring with respect to the flexibility of the launch position and also reduced launch-related requirements at a spaceport. So if you consider certain aspects of the European landscape, so to say, let's say classical vertical launches might be not the most appropriate thing to do from a certain point of view, maybe from Germany as well, without having an official discussion going on about German spaceports. But if we are considering ourselves to have a look at these kind of opportunities, the idea was here to dig deeper into a use case which is launching from, let's say, departing of a spaceport in the northern Germany area, performing an air launch operation. And the example we used was to have a look at the polar or sun-synchronous orbit with an inclination of 97 degrees as a starting point. And we started to, as we are not currently performing these kind of operations, starting to look into historic data. And what we picked was a historic data which has been used also in another study by FAA, which was orbital Pegasus XL launch from the IRIS mission, originally launched from the Vandenberg Air Force Base in California on June 26 in 2013. Well, how to adapt this? So the idea was for the use case to, let's say, have the spaceport located here in the northern part of Germany at the coastline. So we have our, let's say, transfer into the launch area and into the drop zone area. We made use of existing so-called military danger areas. It's the EGD 323 Charlie and Delta over here, which is marked here, and then launched with a trajectory of 97.8 degree. What we wanted to do is to assess now the, let's say, added impact of this launch operation. So in our studies, we have not considered, let's say, effects from using these kind of danger areas, as they are already used frequently for military training. So what we wanted to find out is how much effect is it on top of that. Therefore, we started to model our restricted airspaces, starting from, let's say, the historical information. You can see here the original flight restriction areas, which has been related to the IRIS launch. We mirrored those data, those two flight restriction areas, which has been published in a NOTAM from the historic NOTAM information over to the northern sea area. You can see here a little bit of Scandinavia, a little bit of UK. Aligned it a little bit closer to, let's say, the inclination, and then performed a fine adjustment of the polygons because our original transfer made some conflicts here at the oceanic entry point at one of them. So to avoid that, we made some fine adjustments and come to those two polygons, the yellow ones you can see here. There was a third one, which has been performed in the historic launch, which would have, by the transfer, reached somewhere in the polar region, which we don't want to access here, so we really concentrated on those two flight restriction areas. So what actually are we doing with these kind of data? So our research question was to find out what kind of influence does these kind of operation, or could these kind of operation have on European air traffic management? Is it possible in general to integrate it? How much impact does this space flight activity have on surrounding flight? And how much, if we consider this kind of impact, is the flight duration increased for affected flights if they have to avoid those areas? So we performed some simulation using entry count, exit counts of these flight restriction areas, total flight duration, total distance flown. We have used a traffic scenario from July 1st, 2016. Actually, 3 scenarios which has been run with around 36,000 flights simulated. The tool we are using for that is AirTop. It's a fast time simulation tool which has been used widely in, let's say, the ITM domain, and also some, let's say, DLR internal simulation and pre-processing tools. We have used Eurocontrol DDR2 database for modeling the airspace structure for the European airspace, and also to get the flight information for the used scenario day. And that was then applied to those affected zones. You've already seen these pictures here. So scenario 1, our baseline scenario, represents the status quo, so we just run the traffic through those areas. Scenario 2 was meant to consider a period with lowest traffic demand, so that we can have a closer look on that, on the effects. And in scenario 3, we want to consider the period of peak hours, so the maximum impact, how much would that be? As it turns out, we only needed 2 scenarios, of course, the baseline scenario. And when we performed our runs for those 2 additional flight restriction areas, actually, we had closed them for 1 hour. And we had a sliding, we slided this 1 hour with 10-minute steps through the day. And you can already see that there are certain times where we have no impact at all of those flight restriction areas. So scenario 2 we could put away on that. The maximum impact we had was a number of 17 flights in that 1 hour, and that was actually the one we wanted to analyze a little bit further. So you can see the simulation results here. We had a look on those 17 flights. 3 ones are not considered in that list. I will tell you about that later. You can actually see the yellow tracks here, which were the original tracks in the simulation to go through those restriction areas, and the green trajectories, a little bit hard to see here, are already the, let's say, the reroutings we performed to find out if you have to avoid those areas, how much impact that would make. And you can see, actually, due to those rerouting effects, the delay numbers we have calculated from that, and the difference of the distance flown in nautical miles. And you can see also that already, let's say, the rerouting here was performed not in an ideal way, so there are still some place for improvement. There are 3 flights I was already talking about, which are shown here in the diagram with the increase of the original route in percentage. Those 3 flights from WOW Airlines here somehow in the simulation performed weird in a certain way, because our manual rerouting function has not worked properly, so we throw them away in our analysis results for the time being, because those values could be much better. But you can see here, for most of the parts, let's say the increase in the original route is below 2%, except for one on those 3 unfortunate flights. Same applies in the amount, let's say, in the increase of fuel burn here. So there are effects in this kind of worst-case scenario, but there are certain limitations to that which we can consider. If you have a closer look at the simulation results regarding the flight categories and what kind of flights have been affected by those reroutings, you can see that, it's basically, of course, dependent on which kind of areas we have used and where we have positioned the launch operation. That due to the fact that it's very close to the oceanic routes, we have, of course, the most impacts on those long-haul flights for this, let's say, worst-case period, 24% medium-haul flights. And the region of departure airports of those flights, 50% is coming from Europe, 37% from Asia, just 9% from North America, and 4% from Russia. On the other hand, the region of the destination airports are quite different. Here we see North America with 69% on the front, 2% for Russia, 29% for Europe, none for Asia. Nevertheless, this is just to give you a picture on this kind of worst-case scenario, which we have assessed here. If we have to consider, of course, certain assumptions and limitations. So for the time being, we have just used historic traffic data as for the launch activity as well as for the air traffic scenario. We have left out one of the polygons because it was far away. We considered that not be part of the European airspace, but nevertheless, there might be some additional impact on that. And by the way, we also have not really considered the effect of the already existing danger areas where we have positioned the drop zone. So with that in mind, we also did not calculated optimized rerouting, which can actually limit the effects a little bit more. Controller workload has not included, no weather, atmospheric data, no alternative measures to avoid rerouting for the time being. So certain effects coming into place here for our analysis. Nevertheless, the use case which we have shown here was a potential air launch scenario within the North Sea region between Great Britain and Scandinavia. Historic launch data has been used. And we have made an analysis of the 2 additional flight restriction areas. So important for us was that we had several periods with no or only small traffic flow through those polygons. And the maximum total occupancy within those polygons were those 17 flights I have shown you, which is, of course, if you do a planning of these kind of operations, you will not do the operation in exactly that time because you would like to minimize, of course, the effects you would have on that traffic. So the main conclusion for us was that depending on the launch trajectory and also on the location of the flight restriction, air launch operations can be designed with only limited impact on air traffic operation. That's very important for us to access this kind of operations in a very busy, of course, European airspace. So what's the outlook? As you have seen, we just had a look at, let's say, basically one traffic setup. So variation of traffic samples, but also launch trajectory is one thing we want to have a deeper look at. Using of air traffic flow management with procedures like holding at gate and airspeed control that could reduce impact of rerouting and by that also reduce cost and flying time. Integration of dynamic airspace, we have heard that terms today as well. So limiting airspace closures and also incorporating dynamic hazard areas so that we have this kind of more dynamic way, not closing the airspaces for 1 hour straight, but really have appropriate ways to limit the duration and also maybe to optimize the shapes of those restriction areas. With this, I'm at the end of my presentation. Thank you very much.
Thank you. The final speaker on this panel, fortunately, her paper ends with "and finding solutions." So, Janet, I look forward to hearing how we're going to solve these problems.
That looks like us, right? Good. Okay, so thank you very much for letting us come here today and help find solutions. I actually, this is a true collaborative effort. My colleague, Dr. Chunyan Yu, is actually in the audience as well. And we work with the NEAR Lab at Embry-Riddle, who also helped fund this research. We started this research a couple of years ago, looking at the impacts of launches on airline activities. And I think it's great that we're all together here now because first you have to agree that there's an issue. And there is an issue. And some of the issue came from the fact that commercial airlines were used to flying around military and government launches, but now they have to fly around commercial launches. And we have 2 commercial entities vying for the same airspace. To add to that, though, aviation and space, they've been tied together for decades. And I would bet most of us in here are both aviation enthusiasts and space enthusiasts as well. And I think that's important to recognize. The research that we started working on, again, looked at impacts. And then we started trying to find solutions after speaking with SpaceX. We spoke with the FAA. And our initial look was out of Cape Canaveral using an Atlas launch. And then we decided to move forward and look at a little bit closer Cecil Air and Spaceport. There's a lot going on there right now. As we go through these slides, I'm going to briefly talk about some of the literature. Actually, some of these papers were written by colleagues that are in the audience right now. The first 2 were FAA papers. So we've been addressing this impact for a long time, addressing how to integrate air and space together in our national airspace system. We've looked at adding buffer systems. We've looked at the space data integrator. There's something called compact envelopes that individuals have looked at. We just talked about dynamically changing the restricted areas. And certainly some of these papers have brought more information to the problem as well as trying to seek out solutions. So I'm going to move on to what our research tells us. We looked at Cecil. We used I have to step around, I have to see here. We looked at several scenarios, actually, out of Cecil using Virgin Galactic. We looked at the Concept Z profile. Let me see if I have here we go. So there's Virgin Galactic. And if you know anything about Cecil, they have a flight corridor here and a temporary flight restriction for the Virgin Galactic system, and this is Spaceship Two that usually launches above about 40,000 feet. 4 scenarios. We went through 4 scenarios. The first one was, let me get my pointer here again. We looked at the complete TFR, and we blocked airspace from 8 to noon, so a 4-hour swing, 2 hours before, 2 hours after launch. We actually used a 10 a.m. launch versus a 9 a.m. launch. If you look at the Cecil airspace agreement, they recommend or they want launches before 9 a.m. We chose 10 a.m. because it was slightly crowded, well, it was more crowded airspace. We wanted to address those impacts. Scenario 2, we have the complete TFR of blocked airspace, but we reduced it from 9 to 10:30 a.m. And that was based on discussions with FAA. This would have been the Jacksonville En route Control Center area, where they said, and actually SpaceX said the same thing, typically 30 minutes after launch, without an anomaly, airspace is clear. And they actually start opening the airspace to airlines. Scenario 3 was from 9 to 11. There was also some evidence that an hour before, hour after are some of the current assumptions with respect to Cecil. And then scenario 4 was we treated the carrier aircraft with the mated aircraft truly as just an aircraft. And that comes from looking at, for instance, L-1011 launches with Pegasus out of Cape Canaveral is actually treated as just an aircraft. So this is what I just said. We had complete, this is the corridor I was talking about, the restricted airspace with the different scenarios. And then with the 4th scenario, we actually took out that particular flight corridor. So Cecil's up here, arrivals coming in from the south. That's what they plan on, departures from the north end of the runway. This is intriguing when we start looking at the impacts. And I'll brush back to those particular scenarios in a minute. The other thing that we actually looked at, and I just have a picture here of what's going on in Florida. But when we talked to ZJX, they said typically what happens is that they funnel the airline routes around the area down the peninsula of Florida. That would be what would be typical. And we only studied primary impacts or primary effects, meaning if the airlines were rerouted around Cecil, we didn't also look at other airlines that were also rerouted because of the reroutes, so to speak. We took May 2nd as 2017 as a very busy, as our actual air traffic data that we used, and we forecasted out 10 and 20 years out from there. And then we started to see what was happening. And this is what was the most interesting. I said I would talk about these scenarios. This was 8 to 12. This was our scenario 1 from 8 to 12, launch at 10. Full corridor. This one was 9 to 10:30, 9 to 11, full corridor. And look what happens when we remove that one corridor area. So I'm going to fly back here for a minute. That right there. It's this piece. So then we started looking at, well, why did that make the biggest impact? Well, that's where most of the airlines are flying. So eventually, when you start looking at it, you're going to see that once we become more knowledgeable about Virgin Galactic and some of these carrier aircraft systems, if they can truly operate as an aircraft when they fly out and return, then we can get rid of some of that flight restriction. These were the total delay in minutes. You can see they were about 600 in 2017, and went to 700 and 800 in the original scenario, but really dropped down considerably when we took away the flight corridor, or the air corridor there. The worst case single delay under scenario 1 was actually 12.28 minutes, and the ALPA paper showed 8 minutes average. We did read through it, 8 minutes average out of the Cape with the SpaceX launch. If you look at operating costs associated with those delays, anywhere from about 40,000 up to about 50,000 scenario 1, and then when you start, altering the times and altering that flight corridor, they can drop significantly. And I'm going to reiterate that again, these are very spaceport specific, because as we start looking at different spaceports, those numbers are going to change radically. Fuel costs, about 12,000, 14,000 up here, down to less, it looks like less, maybe $500 or so. So a considerable drop. And not sure if there's anything else I can say about those particular things that we looked at, except for that gave us a true view into what are some other things that we can do besides changing the shape of areas. We did not look at dynamic changes of area here. We kept the flight restrictions the same. But then again, all we did was we started moving the flight time, the closure window, and we just changed that one area of the flight corridor, assuming that it was going to be acting more as an aircraft instead of a space launch, so to speak. In the end, probably the best solutions are going to be some sort of hybrid as we talk through these, a hybrid between changing the restricted areas as well as changing the times that the airspace is closed. Again, very specific to the spaceport location, the launch time, and of course the vehicle. If you've been reading the paper about Cecil Spaceport right now, and Generation Orbit is one of their first clients. They are launching, I think is it this year? Yeah, okay, this year or so. They're starting to launch this as, again, this is a carrier aircraft with, I had to look this up, the particular rocket that they were looking at, it was a LOX kerosene propellant. So other things that we're looking at, of course, are other stakeholders, the secondary effects for flights that we didn't even get a chance to look at, some of the other direct and indirect consequences of these launch return activities, like what happens to the airport, right? If there are these subsequent time delays or flight delays, what happens to the airport, their operations, and of course, other spaceports with alternate launch vehicles. And, how does that impact our FAA procedures around the world? And that's it. Thank you.
Thank you, Janet. I think you could tell by how twisted around the panelists were, how interested everyone is in that presentation. I think that you did a really effective job of illustrating why Katie's paper is important as well. If we have that shared information from the CDM processes, small decisions can make a significant difference in reducing the impact we have on one another. So with that, we get to open it up to questions, and I have to go to Moriba first, of course.
So hopefully people in the back can come here. I think, interesting talks for sure. Certainly a lot of high-level processes, that sort of stuff. I get it. I guess one of the things that I'm finding unfortunate, and maybe the next panel will start dealing with this a little bit more, is there's no mention whatsoever about uncertainty. That's the thing that really bugged me about the whole thing, is that here we have these paths. We're gonna block off all these areas, And I'm like, okay, I want, the analogy to me, and this is nothing personally against any of you, this is just general kind of thoughts, is that I'm thinking to myself, well, I wonder if when they discover that there are a few people that are dangerous in Austin, if they shut down all traffic into the Austin area and reroute people to go through Dallas or something like that. They don't do that. Okay? Yes, there are dangerous people in this city. Guess what? A lot of them are around 6th Street and I-35, unfortunately, by a homeless shelter. So avoid that area for sure. Maybe if you're out in the West Lake area, it's not so dangerous. My point is this. We're not being surgical about any of this stuff. If you took all the errors in air traffic patterns and launch vehicles and all that stuff and did massive Monte Carlos with actual errors, do you know what you get? You don't get ellipses, you don't get polygons, you don't get any of this stuff. Because that's not reality. That's this conservative measure to block all this stuff off because we have no idea what the real uncertainties and errors are. That's where we need to focus a lot of the work, is trying to quantify that ambiguity so that our decisions can be more surgical and not this kind of blanket, I'm going to block off 4 hours to prevent this, that, or the other. That's where things need to head. And so I would implore that all of you in your own work find ways to motivate that and incorporate that into your analysis so that, because one day, the future of space travel, as far as I see it, is one day I'm going to be flying in my Cessna 152 and a couple miles away I'm going to see something launching. Right now, we can't even fathom that sort of situation. So, if anybody has comments to any of that, I'd love to hear it.
I can't believe I'll take it. Sure.
Okay.
I was going to keep my mouth shut, but it is being explored, and that's kind of what I was trying to say. The technology is there, and that's that little bit where I'm trying to say, going from the theory to the reality is the dynamic airspace is there. I mean, the capability to do that is there. Now, to get that into the reality phase, to be able to take that box of airspace and now put it on the controller scope from this big, where it is right now, down to that small dynamic airspace, using a smaller amount of time, using a smaller airspace, is there. But now, how do you make it into reality? How do you execute that plan? That's the hard part right now, and that's that collaborative part that we talk about is we know it's there. We know the tools are available, but how do you get them onto the controller scope? That is where we're really having that big mix. I'm working on safety panels that are exploring exactly that. I'm working on the rulemaking committees that are working on exactly that, what you're talking about. So it's being done.
And I'm going to use a little moderator's privilege to intervene in this as well, because that's where we have a model from aviation. And we have, if we look at the history of aviation and sort of look at the history of space travel, we started with 100-mile separation standards between aircraft. And we're down to, in some cases, 1.5 miles. And the difference was having that data and improving the systems and the data and the ability to evaluate the data and to trust the data in order to have smaller and smaller separation standards. So the path that we used in aviation, I think, is very much the path that we need to use in space to get to exactly what you're talking about. But it's certainly not instantaneous. Anyone else on the panel want to take it?
No, I would just agree with you. The uncertainty is definitely, we can reduce the uncertainty, but to your point, we've got to be able to quantify. We need the data, and that's I think folks are working in that area. So, yeah.
We have a question over here.
So I have two, and it's for Mr. Browning from Alpha. Sorry to pick on you. And I know these are not yours. That it is part of the the bigger Alpha. But you mentioned certification, and while I am all for that. To me, it feels like there's some implied, we're letting anybody fly a spacecraft. And I think if you looked into the certifications that already exist, are you looking that everybody should be under the same certification, the same standards? Obviously, NASA has certifications, Virgin has certifications. Can you give me an idea of what you guys are looking for?
Well, that's exactly what we're trying to highlight is the fact that there are different certifications for what every one of the operators say their pilots are experienced by X, right? And that's where we're talking about the historical, where we stand, the reality of, we have one set of rules that qualifies me as a pilot right now. And that was where we're talking about the experience to fly passengers, right? We don't just let anybody go fly passengers. You got to be experienced. And we even limit the number of pilots now that you can fly up until you have 1,500 hours of flying time. So we do limit very much the experience of the pilots carrying the number of passengers. that's not there. That, just like you said, each one of the carriers is individually certified, and that's kind of what we're highlighting. But if you're going to operate in the same airspace, shouldn't you have that roughly that same qualification that is flying right next to you, whether you're carrying a passenger or a participant? Right?
But from a person perspective, is that necessarily true? Because your certification is very different than the certification of someone who's flying a Cessna. So the person who is flying one spacecraft is going to be different than
Correct.
And in some ways. So I guess I'm trying to understand. I mean, okay.
No.
Am I being clear at all?
No, that's fine. And that's why we have like multiple ratings that, depending on the type of aircraft, but we define those aircraft, right, a little bit better than some of the spacecraft right now in terms of their airworthiness certificates and things like that, the design of the aircraft. But whether it's land, sea, air flights, what category aircraft they are. The thing is, what we're talking about here right now is decades, 100 years of experience, right, that has happened. You're in this development stage right now where you got these real, where are the astronauts in here? And I wanted to ask, I wanted to kind of ask that question too. It's like, you're working for a company, you're training on that specific spacecraft, and obviously they know what they do. We're talking about down the line here as this evolution takes place, where there are, some vertical launches, some horizontal launches. How do you begin to define that when there's a fleet of aircraft and I'm just Joe the astronaut who gets hired by the company now is going to go fly this airplane and for the spacecraft and go out, and so that's the kind of definition we're talking about. But it's going to happen overnight. Right?
So you're not championing that this needs to happen tomorrow in order for commercial spaceflight? Okay, I'm just
The segregated airspace may be the solution until such time as that data collection effort begins to build, that the technologies themselves begin to become better, and the risk begins to be lowered, and the airspace, the low-hanging fruit that we just talked about, be able to use and maybe open up the airspace and close it, will change and get narrower and much more narrower and narrower as the technology increases and the safety, the 10 to the minus 6 goes to 10 to the minus 9, and then you're there, right? But it's not only, it's not.
If I could just pause you for a moment, because we do have some other questions and we have 3 minutes. Sorry about that.
Thank you. I appreciate that clarification.
Yes, please.
Yeah, following on the same conversation, first let me state that I'm all for safety because of what I did before, and I'm on the Aerospace Safety Advisory Panel. I get that, and I do think we need to learn the lessons of aviation, because the less that we can do regulation by bloodshed is I'm all for that too. However, listening to this conversation, it strikes me that, and especially again, Alpha, and I understand this is your lens, but you're looking at this integration problem from how do we take what's going on in commercial space and stuffing it into the box of everything that we know that we've done before and the way that we've done everything before. And it strikes me that perhaps as a community we ought to think about, 100 years from now, what do we want our system to look like? And let's envision that and then work backwards a little bit and figure out how to get there slowly, with the understanding that, there's time and money and technology, but I think we're trying to approach it from the ground up without letting ourselves be a little bit more visionary and creative and opening up our solutions space a little bit. And I don't know if those conversations are going on or not. This is my first interaction with this community, but I would just like to throw that out there for discussion or comment.
Actually, no. But Sven, you can respond.
I mean,
yeah, it will be, and there's a break coming up, which will be a great time for that interaction. So if I could let my panelists answer the question, that'd be fantastic.
Just would like to raise the point here that we're talking a little bit about manned spacecraft to manned aircraft, but a lot of the spacecraft we are considering here are unmanned vehicles. So we can more or less maybe compare it into the discussion on how to integrate unmanned air vehicles into that. We know that for the certification part, that's very hard. We know that there is a pilot for a reason, because he's enhancing the target level of safety, or he's part of that equation. So we are bound a little bit in this to have those both points. So we want to be with an increase in the target level of safety, to be as close as we are currently in air traffic. On the other hand, we have to deal with the uncertainties we've just heard, and Moriba, I think you made a very good point. So trying to narrow that down, but for the time being, we cannot be as sure about, of course, safety, but also of, let's say, prediction of flight trajectory. We have For air traffic, we have 4D trajectories. We try to get this kind of business trajectories into operation. That's part of NextGen, it's part of CESAR in Europe. So we are making 4D trajectories with pinpoint accuracy in not only where to fly, but when to be. And we have to try to squeeze that in. And to have these kind of unmanned systems and unmanned rocket and unmanned vehicles, whatever it is, into that certification has been trying to get, let's say, this kind of third way of taking this kind of specific, as EASA is doing in Europe, specific categories, which takes into account also the mission and the performance of the vehicle and tries to narrow down the uncertainty level, but make sure that we are taking that into effect, that we are able to allow these kind of operations. So I think on the one hand, there will be a change in the air traffic management coming out of UTM, for example, unmanned traffic management, much more technology on the level, much more real-time capability of our tools. We have technology, but it's not implemented yet in that way. So the pieces are coming together. We're on the way, but there will be a transition period for that. And the end system will look different than we have our system today.
And unfortunately, we've come to the end of our time. We are going into a break.